topic is electrochemistry. Right. Have you seen dry cell? Yes, please. Yes, but have you all of you seen the dry cell? Yes or no? Okay, fine. So, what is this dry cell? Can you tell me a little bit about it? Yes, let me know. What is this dry cell? You might have seen a button cell also, very commonly known as a button cell. Have you seen? Yes. So what is this button cell or dry cell? Which has two and one positive, one negative. Okay. So have you seen a battery that is used in the inverter or in your vehicle? Yes. So what is your function? All these things, what are all these things, whatever I'm telling you, like a button cell or a dry cell or that battery used in inverter. What are these? Basically, what are the chemical? Yeah, source of power. So which process is producing? Process is producing the power? Which process is producing power? Electrical power, right? Is produced from what? Yes. Please participate. All the students, please participate in the discussion. It is not a one-way interaction. It's a two-way interaction. Yeah. Very good, Ame. It's a chemical energy is being converted into the electrical energy. Fine. Absolutely perfect, Ame. Very good. Now, it means we can convert the chemical energy to the electrical energy, right? When there's a power cut, right? Your inverter starts working, the battery starts consuming. In that case, the chemical energy is changed into electrical energy. Now, after some time, the power comes back, right? So now what happens during the recharging of this battery? What happens in the recharging of this battery? What change takes place here? Yes, all of you students, please participate in a discussion. What happens in this? When my question is, uh, suppose there is a power cut right now, right? Then the inverter of your home starts working and converts the chemical energy into electrical energy that provide the power. Getting me? Now, after some time, the power comes back, right? Then you say the battery is being charged. It got discharged when it was providing electrical energy, but now it is getting charged. So what is happening here? Electrical to chemical. Absolutely correct. So here, electrical energy is converted into chemical energy. Right? Very good. So in this chapter, we will be discussing how the chemical energy can be converted into electrical energy or electrical energy can be converted back to the chemical energy. Getting me? So this studies of chemical to electrical, electrical to the chemical, and relationship between all these things, two forms, is called as the electrochemistry. So the branch of chemistry that deals with the study of relationship between the electrical energy and the chemical energy and interconversion of the above two forms is called as electrochemistry, right? Getting me, all of you? Right. Now, we'll be discussing all these things in detail now. First of all, I'm discussing one very famous experiment done by Michael Faraday. Very famous experiment. What he did is, he dipped zinc rod in copper sulfate. Zinc rod in copper sulfate, right? What was our observations here that I will not discuss here? Observation is, number one is zinc rod is eaten away. Zinc rod is eaten away. It means it happens like this. This is the beaker here, and the zinc rod is getting dissolved like this. Number two, copper metal deposit at bottom. Deposit at bottom. Right. Number three, the blue color of copper sulfate solution this fades away. This is our practical observation. Getting me, all of you? These are the practical observation. Now, what is actually happening over here is, in this case, zinc is getting oxidized. You can see zinc is getting oxidized. You know what is loss? What is oxidation? What is oxidation? Please respond here. What is oxidation? Loss of electron. Yeah, very good. Increase in oxidation number. So you can see that zinc is getting oxidized. So this zinc is coming into the solution. Zinc is coming into the solution, right? And the copper ions are getting reduced. Copper ions are getting reduced, means the electron lost by the zinc are taken up by the copper ions and they get deposited at the bottom. Can you tell me what is reduction? What is reduction? See first. Very good. Gain of electron. So the copper ions are gaining electron and become copper. Right? So in this case, what is happening is zinc is losing electrons and copper is gaining electrons, right? Are you getting me? And so that reaction is called as a redox reaction. That reaction is called as a redox, in which the reaction is involving two phenomena. One is called as a reduction, RED for reduction, and OX for oxidation. So that process is called as a redox reaction. Is that right to pronounce? Redox? Lal Bell? Okay, fine. So it is a redox reaction. Technically, we call it a redox reaction, but it's basically a component of two things. One is the reduction, other is the oxidation, right? In this process, what is happening is this zinc is losing electron. See here, very important thing. Zinc is losing electron, so it's a loss of electron. Copper ions are gaining electrons and become copper here, right? And if you add the two, I'll get this main equation. We call it the redox reaction, right? Now, we call this is the half part of it. We call it the oxidation half reaction, and this is the reduction half reaction. And if we combine the two equations, we get the redox reaction, right? Fine. In this case, what is happening is the electrons are transferring from zinc to copper. Electrons are being transferred from zinc to copper. So electrons are flowing. Can you tell me what is meant by the flow of electron? What do you call when electrons are flowing? When electrons are drifting, what do you call it? I repeat my question. The flow of charge, very good Lalit, flow of charge, the negative charge is current. It means the chemical energy is converted into electrical energy, right? Now, my important question here. Suppose I now dip two wires here and place here a bulb. Will the bulb glow? Yes or no? Will the bulb glow? Wow. All of you say yes. Very good. Great. Now listen to me very carefully. Do you find the condition for the current to flow here? In physics, you might have discussed what is the necessary condition for the current to flow. Can you tell me what is the necessary condition for the electricity, for the current to flow? Yes, there must be potential difference between two electrodes. Very good. What is another important condition? One more important condition. One more important condition. Please let me know. Of course, electrons are there. Electrons are there. Free electrons are in the metal. Yes, they are there, already there. The necessary condition, listen to me very carefully here. The necessary condition is the circuit must be complete. The circuit must be complete. Do you find here the circuit completion? Is it a closed circuit? Yes or no? Check. Check in the system. No. It means, first of all, we don't have a closed circuit. Number two, at one end there must be high potential, other end must have a low potential, right? Here, there is no any potential difference. Here, we don't have any potential difference. Getting me? So, the bulb will not glow. What you're expecting the bulb to glow, the bulb will not glow. Are you getting me? But theoretically, what is happening here is, what we are explaining like this. Actually, what is our theory is, electron lost by the zinc, gained by the copper. And in this process, the electrons are transferring, are moving. When they are moving, we say the flow of electron going on, right? And flow of electron means current, right? Theoretically, we are converting the chemical energy into electrical energy. But practically, it is not happening. Practically, it does not happen. Am I clear to all of you? Now, if our theory is correct, that must work. But practically, it does not work, right? Now, we'll be discussing here how to make this cell conducting. But before that, we are discussing here what are the types of the electrochemical cell, right? If it takes sodium chloride solution, will it dissociate into the sodium and the chlorine? Please respond here. Will it dissociate in sodium and chlorine? No. Okay, fine. It will not dissociate. Then in what form they will dissociate? What will happen with the sodium chloride? I have sodium chloride and I had dissolved in water. Then what happens when we mix them? Sodium chloride dissociates into sodium positive and the chloride negative, right? And water dissociate as H positive and OH negative ion. But they do not dissociate as a Na and a chlorine, right? Okay, fine. So when we take sodium chloride in a vessel and dip electrode and pass the current, so what will we do? What will happen there? When I have this sodium chloride solution here, and I am passing here current. It's a H positive, OH negative ion. And now I am dipping two rods here, and one connected to the negative end of the battery, other the positive end of the battery. This small is negative terminal, this big is positive terminal. Can you tell me which is the cathode here? Which is the cathode here? Yes? Negative is cathode, very good. And at anode, it is the positive, right? Very good. At anode, it's the positive. So when we pass current, I have started passing the current, right? Now, what will happen? What will happen? Please participate, right? Fast, and let me know. What do you think when you're passing current? Don't know? Ion moving towards anode and cation move towards the cathode. No, Akash, you're just opposite. This sodium ion and H positive ion will be attracted towards the cathode, right? Okay, okay, Akash, you're right here, perfect. And these are the ion attracted towards the anode. Now, I say at cathode, two phenomena can take place here. Very important here. One possibility is sodium ion can gain electron and become sodium here. Other possibility is the H positive ion can gain electron and become H. Two such H positive ion gain two electron and produce the H2 gas. Are you getting me? Are you getting me? Now, which process will take place? Which process will take place? Whether the sodium ion will be reduced or the H positive ion will be reduced. Akash will say Na positive. Any other opinion? All of you. Please justify your answer also, Akash. Why only sodium? Why not H positive ion? Reactivity order, okay? Yes, all of you. No answer? Are you mute spectators? Okay, Akash. You are wrong here. Actually, the hydrogen will be reduced, not the sodium ion. The reason being, at your +1 level, you discussed about the reduction potential. The reduction potential of hydrogen. Can you tell me what is the value of the reduction potential of hydrogen? Yes. What is the reduction potential of hydrogen? You're not answering. 0 volt, 0.00 volt. And the value for the reduction potential for the sodium positive ion is some negative value, 1.37 volt. Which will be reduced? The one that has a lower reduction potential or the one which has a higher reduction potential? Which will be reduced? The one that has low reduction potential or the one that has a higher reduction potential? No, my dear. It's opposite, the one with higher reduction potential. This is the negative value and this is the 0 value. The 0 is greater than the negative value. So this will take place or not this one. That process will take place which is having higher reduction potential. Here reduction potential means tendency to gain H positive, tendency to gain electrons. H positive ion has more tendency to gain electron as compared to the sodium. So this will take place, not this one. Are you getting me, all of you? Yes. Please participate in this discussion. It's a two-way interaction. And you have to write everything in the chat. If you're understanding, if you're in a doubt, please, it's a two-way interaction. Right? It's like a normal classroom. Right? So hydrogen will be reduced. It means here the hydrogen gas will be liberated out. Am I clear? The H2 gas will come out. Now, at the anode, the chloride and the OH ion will be attracted. Now, what will happen here? One possibility is the chloride may lose their electrons, and two such chloride can produce the chlorine gas. One possibility I'm talking about. Other possibility is the OH ion can lose electron. It will give here two water molecule, oxygen, and four electrons here. Either one of the two process will take place, right? Now, which will take place? Which will take place? Very important question here. That depends upon their another theory that I will not discuss here, that is called as a preferential discharge theory. Preferential discharge theory. Basically, if I say discharge, charge getting discharged, Cl negative converting to Cl2, OH ion converting into O2, right? Now, which will be discharged? That will be discharged, which will require less potential energy, which will require less potential. Now, which require less potential? For that, you have to remember a sequence here. Maximum potential is required by the sulfate ion, then less by the nitrate ion, NO3 negative ion, less by the OH negative ion, then we have a chloride ion, then I have a bromide ion, then iodide ion, and last the H negative ion. That will be discharged first, which require less potential to discharge. So as you can see in the sequence, the chloride ion will require less potential to get discharged. So the chloride ion will be discharged and the chlorine gas will be liberated over here. O not O2. Are all of you getting me? Yes. Are all of you getting me? Yes. Perfect. So this depends upon two things here. Number one, the reduction potential. Number two, discharge potential. I hope it's clear now. Right. So what we are doing here is, here we are passing the current into the chemical. Here we are passing current into the chemical. And in this process, what is happening is electrical energy is converting into chemical energy. Here, its opposite is happening here. We call it is a electrical energy converting into chemical energy. When we pass electrical energy and some chemicals are produced, we say it is a electrolytic cell. We call it is a electrolytic cell. Right? And when chemical energy is converted into electrical energy, it is called as a galvanic cell or voltaic cell, also called as an electrochemical cell. Also called as electrochemical cell. So it means we have two types of electrochemical cell. One is the electrochemical cell, other is the voltaic, other is the electrolytic cell. Is that clear? 100%? Okay. Now, you know what is redox reaction now? The reaction in which reduction and oxidation both take place simultaneously is called as a redox reaction. That you know. So in this process, zinc is losing electron and this is called an oxidation. Copper is gaining electron, it is called as a reduction. Is that clear? So the two things are there. One is the oxidation half reaction, other is the reduction half reaction. Oxidation half reaction and reduction half reaction. Two phenomena are taking place. Right? Any doubt? So the reaction in which oxidation and reduction both take place simultaneously is called as reduction. Right? So oxidation is loss of electron, reduction is gain of electron. Oil rig. Remember here, oil rig. The technique. Yes, if you have any doubt, do let me know. No, no doubt. Perfect. Now, what are oxidizing agent and the reducing agent here? Again, I'm writing here the same equation. Zinc plus copper ions to give copper and zinc ions. Can you tell me which is undergoing oxidation? Which substance is undergoing oxidation? This is undergoing oxidation. Oxidation means it is losing electron or gaining electron. Losing electron. Fine. It means zinc is losing electron. Perfect. Now, will the zinc lose electron by itself? If I have a zinc rod here, will zinc lose electron by itself? No. So in this reaction, what compels the zinc to lose electron? What compels? What is the driving force here so that the zinc will lose electron? I'm very specific to this reaction. What compels the zinc to lose electron? In this reaction, which is the compelling factor? Yes, Akash, you're right here. Copper ion is compelling zinc to lose electron. Right? So this is a oxidizing agent. This is called as an oxidizing agent. The one which compels the zinc to lose electron. Right? Now, which substance is undergoing oxidation reduction? Which substance is undergoing reduction? Very good. Copper ions. Copper ions, right? Now, in this copper ions, they are gaining electron and becoming copper here, right? So, we say copper ions are gaining electron. What is giving these electrons for reduction? Zinc. So, zinc is the reducing agent. Am I clear? The one which gives electron for the reduction is reducing agent. The one which takes up the electrons, which compels the one material to lose electron, is called as a oxidizing agent. Am I clear to all? Yes. Anybody, any doubt? Do let me know. How does copper help zinc to lose electron? Okay, that I will not tell you. Very important. Now, what makes the copper ions? Actually, what is happening with the copper ions so that zinc will lose electron, right? Okay. What is that mechanism? Why will zinc lose electron in the presence of copper ions, right? That's a very important question. I'll discuss this. Now, so before I go ahead and I'll discuss that mechanism also, Nirul, oxidizing agent is the one which oxidizes the substance and gets reduced itself. It's called an oxidizing agent, right? So it gains electrons. Reducing agent is the one which reduces substance and gets oxidized itself. It's called as a reducing agent. Am I clear to you? So is this clear now? In this reaction, copper ion is the oxidizing agent and zinc is losing electron and reducing agent. All clear to all? Perfect. Now we discuss about what is meant by the galvanic cell or the voltaic cell, right? And in this cell discussion, I discuss about that mechanism also, which compels the one substance to lose or gain electron, right? So the device in which chemical energy is converted into electrical energy by spontaneous redox reaction is called as a galvanic cell, also called as the electrochemical cell, also called as the voltaic cell, right? These cells have been named in the honor of Italian scientists Louis Galvani and Alessandro Volta. It's a Louis, not Luigi, not Luigi or Luigi. It's a Louis. G is silent here. Luis Galvano and Alessandro Volta. Am I clear to all? All right. So in the galvanic cell, a redox reaction is carried out in the indirect manner. Electrical energy is produced. Indirect redox reaction. Reduction oxidation take are in separate vessels. Okay, in separate vessels. What is the meaning of the separate vessels now? In that experiment, remember the experiment, zinc dipped in the copper sulfate. Zinc dipped in the copper sulfate. I told you that zinc undergoes oxidation, copper ions undergo reduction, right? And we say redox action is going on. Electrons are flowing from zinc to copper. But when we put the two wires and try to use that electrical energy into bulb to glow, it does not give any such voltage difference, right? The two problems that I discussed over there, number one, the circuit is not complete. Number one, circuit is not complete. Number two, what is that problem? Potential difference is not developed between the two end of the conductor, right? Two problems. So that two problems were solved by these two scientists, Alessandro Volta and Louis Galvanic. He took two beakers here. In one beaker, copper sulfate 1 molar, and in that beaker, copper rod was dipped. Will some reaction take place? Will some reaction take place when copper is dipped in the copper rod, copper sulfate? Yes or no? No. And another case, zinc sulfate was taken, 1 molar, and zinc rod was dipped in it. Will some changes will be observed? No change. Good. Now what we do, we connect these two wires with the voltmeter. This is the voltage V, right? And observations now, very important. I will now discuss some very important observations. Number one observation, zinc rod is eaten away. Again, it is dissolving. Number two, copper metal deposit at copper rod. Getting me? Copper metal is getting deposited at the copper rod. Blue color of solution disappear. Blue color of copper sulfate fades away. Yes, it is getting eaten away like this. Yeah. When you connect it here, when you connect this, then it is observed. Yes, Srija? When you connect this, it is observed that zinc rod is getting eaten away. On the copper rod, copper is getting deposited, and the blue color of the copper sulfate fades away. Another is a voltmeter. Show deflection. Voltmeter show deflection towards zinc. Voltmeter show deflection towards zinc like this. Number 5, this cell stops working after some time. The cell stops working after some time. Very important here. These 5 observations, now I will discuss the 5 observations one by one. How it is happening. When we connect here, this zinc lose electrons and undergoes oxidation. So the zinc comes into the solution. So I can now say the zinc is eaten away. Is that clear? Are you getting me? Good. Please, all of you students, participate in the discussion. And now, very important, it is losing electrons, so it is giving electron to this one. So electrons are flowing from the zinc to copper. This is a source of electrons, so it is a negatively charged. Am I clear? It is giving electrons, so it is negatively charged. And it is attracted towards positive, this becomes positive here. When electron reach on this copper, from this copper sulfate solution, the copper ions get attracted over here, and the copper ions gain electrons and become copper. That is why I say the copper metal deposit at the copper rod. Is the second point clear? Is the second point clear? Good. Second point is clear? Right. So the blue color copper sulfate fades away. Blue color of the copper sulfate fades away. Blue color of the copper sulfate fades away because the copper ions are getting out of the solution. The copper ions are getting out of the solution. It means getting me? The blue color will fade away because the color is due to the copper ions. So you should know here, oxidation always takes place at the anode. So in this electrochemical cell, this negatively charged is the anode, and the positive charge is the cathode here. It is the reverse of the electrolytic cell. It is reverse of the electrolytic cell. Cathode is here positive, anode is negative. So we say this reaction is taking place at anode and this is at cathode. Am I clear? Am I clear? Right. At cathode, at anode. 100% clear to all? To you, all of you? Fine. Now, electrons are flowing from zinc to copper. So I say this is called as an electronic current. This is called as an electronic current. And all our instruments are constructed in such a way that electrons are moving from, that the current flows from opposite to that of the electronic current. This we call as a conventional current. This we call it as a conventional current. Are you getting me? Electronic current from zinc to copper and conventional current opposite to the electronic current. It means that our instrument voltmeter shows deflection opposite to that of the electronic current, and that is called as an conventional current. And so fourth point is clear to you now. Is the fourth point clear? Yes or no? Now, another point, last point. I'm coming to the last point now. The cell stops working after some time. Even though our zinc is not completely consumed, copper is not completely consumed, even then the cell has stopped. Clear? There is a problem. Why it has stopped? Then only we can find out its solution. First of all, we find out the reason, and then we will try to find out its solution. Initially, when nothing was connected, zinc ion and the sulfate ions are in equal quantity, means 1:1 ratio. But after some time, what happens? The zinc ion become more than the sulfate ion because of the oxidation. So this carries extra positive charge and it carries the positive charge over here. It contains extra zinc ions, so it carries the positive charge. Here, the copper ion concentration and the sulfate ion concentration, they are equal in the beginning, but with the passage of time, what happens? The copper ion goes to the deposit over here, and the concentration of the copper ions become less than that of the sulfate ion. Right? So this sulfate ion become more, and the negative charge is accumulated here. Now what happens? Very important thing. Understand here. This electron is negative charge, this positive charge, and it will try to attract. It means this solution will not allow the electron to move away from it. And if by chance some electron come over here also, they will be repelled by the negative field of the copper sulfate solution. Negative field repel the electron cloud. Positive field attract the electron cloud. So net movement of the electron will stop. Net movement of the electron will stop. Am I clear? That is why the cell stops working after some time. This is a very, very important concept. Why cell stops working after some time? Any doubt? Ask me now, because this is a very basic concept. You might have done the +1 also. If not, get it clear right now, because after that we'll go into detail, some details, which are typically at the +2 levels. Yes, Gurleen. Should I repeat why cell stops working? Yeah. Okay. Please, all of you listen here. Very important. In this zinc sulfate solution, when nothing was connected, the cell was not connected, the zinc ion concentration is equal to the sulfate ion concentration. But with the passage of time, zinc comes into the solution, extra zinc ion produced. It means in this solution we have extra zinc ions that will make it positively charged because we have extra zinc ions. In the other beaker, copper ions are equal to sulfate ions in the beginning, but with the passage of time, copper ions are less than that of the sulfate ions. Copper ions are less than that of the sulfate ion. Is that clear? So sulfate ions become more, and it creates a negative field over here. These electrons are negatively charged. They will be attracted back by the positive field here, and if some electron reach over here, they'll repel it. It means basically electron flow will stop. And if electron flow stops, the cell stops working. The cell stops working. Any doubt here? I hope it's very, very clear now. All the 5 points, all the 5 observations are clear. Why zinc rod is eaten away? Why zinc rod is eaten away? Because zinc is getting oxidized. I will repeat. Wait. Copper is getting deposited to copper rod because copper ions are getting deposited, because copper ions are getting reduced. This point is clear. Blue color fades away because copper ions are going out of the solution. The color is due to the copper ions. Now, Chitransh, I will answer your question. The 4th point. The voltmeter showed deflection towards zinc. Why? Electron flow from, you tell me, electron flow from zinc to copper. This is called electronic current. But our voltmeter or any other device which shows the flow of the current shows the deflection opposite to it, opposite to the electronic current, we call this as a conventional current. Opposite means electron are moving from this to this, so the current will be shown by the opposite direction. Chitransh, I hope it's clear now. And last point is also clear to all. Yes. Now, another one question was raised over by the Shrija, I think. Yeah, Shrija. Is the circuit complete here? My answer is again no. You can say no. The circuit is not complete yet. You can see. So the cell also stops here by the that problem also. Now we'll solve the problem now. We'll solve the problem. First to understand, see here what we have discussed. Zinc losing electron, copper gaining electron. Is that clear? This is what we observed. See, to solve the problem, we are introducing here a concept of the salt bridge. Very, very important here. This is called a salt bridge. Right? Are you getting me? I'm now solving that problem so that cell will keep on continuing working. Now this salt bridge is an inverted U-shaped tube, as you can see. Here I have a cotton plug, and in this salt bridge we put here either potassium chloride or ammonium chloride and agar gel. And agar gel, right? Now, in this zinc config, in the zinc one, we have excess of what? Zinc ions. We have excess of zinc ion, and here I have excess of the sulfate ions. So here the potassium chloride, let it be filling here the potassium chloride, the extra zinc ions will be absorbed by the salt bridge, by the potassium ion. Here extra sulfate ions are absorbed by the chloride ion. And these two cells become now electrically neutral. These cells become electrically neutral and the cell keep on working until whole zinc is oxidized and until whole of the copper ions are getting reduced. Now it's clear? Okay, good. So, due to the oxidation occurring at zinc, it becomes source of electrons, acquire negative charge in the cell, and due to reduction process occurring at the copper, it is called cathode. I hope this is very clear that I have already explained here. Right? Shrija, which part is confusing here? Let me know. Its function, the salt bridge function is only to absorb the ions so that the two half cells become electrically neutral. So that the two half cells become electrically neutral. That's it.